a triangle, and we are given the tan ratio. Tan of C is 0.8. And we're supposed to determine what sine C is, cos A, and tan A. The problem is we don't have any sides. We don't have any angles either. So one way that you could, in theory, do this is you could start to figure out the clues by taking the tan inverse of both sides and figuring out what C is. So if we were to do that, I can tan inverse 0.8. And it turns out that this angle here is approximately 38.6598. So it's an irrational number. It's going to run on forever. So you could determine sine C at this point by just punching in sine of this. And then you could minus from 180 and determine cos of A and tan of A, etc. So we can actually come up with that. But what if they asked for exact values? The moment you only go to 4 decimal places, it is no longer exact. But can we do this using exact values? Well, to do that, you're going to have to take a different approach. Tan of C is supposed to be the opposite over the adjacent. We don't have those values. So I'm expecting opposite over adjacent to be a fraction of some sort, but they've given me a decimal. But I can actually convert that decimal to a fraction using mathfrak in my calculator. And if I do that, then I'm going to get 4 over 5. So I could label my opposite over adjacent as 4 over 5. So knowing 2 of the sides, we're supposed to be able to find sine C, which is opposite over hypotenuse, according to SOHCAHTOA. We have the opposite, we don't have the hypotenuse. But actually, we could determine the hypotenuse using Pythagorean. So 4 squared plus 5 squared is 41. But 41 is not the length. You got to square root it, right? So this is the root of 41. Now you could change that to a decimal, but remember when they said exact values, they don't want you to round anything. So I'm going to leave this as root 41. So if I'm asking for opposite over hypotenuse, you're actually looking at 4 over root of 41. That's going to be your sine ratio. For cos of A, you're standing in this corner. So you need to think about whether this is still the opposite, which it isn't. So cos of A, you want this adjacent over the hypotenuse. So this is also 4 over root 41. Notice how it is possible for these two things to be the same. They're different angles, but this one's a sine and that one's a cos, and these happen to be the same. What about the tan? So again, we are standing in this green corner over here for tan A. So opposite over, oh wait, no, this is the opposite then. Opposite over adjacent, so 5 over 4. And so these are in exact values here. These with the root 41 in the bottom. So you can actually determine the exact value of it without ever having to go through and determine this. We didn't even use this value. Okay, all you got to do is figure out possible values for all the 3 sides in exact value form. So to find angle F, we're actually asked to determine all of these things. We're actually asked to solve the triangle here because finding everything means solving the triangle. So angle F is 180 minus 90 minus 23 because all the angles in a triangle have to add up to 180. So don't overcomplicate it. This one is 67. So we have this one, 67 degrees. So the next one we're asked to find is FH. So I just going to label this X to make it easier for me to work with it. And we have this side and this angle. So if I stand in this angle, then this is the hypotenuse and this is the opposite. So it looks like I'm using a sine. Sine of 23 is opposite over hypotenuse. So X is going to be 80 over sine 23. If you don't know how I rearranged that, time to go back and watch some more videos because I did that, I think, in lesson 2, 3? No, probably more like 4. So 80 divided by sine of 23 is not 80, 8.0. So I'm getting 20.0. 20.4744. And they wanted to one decimal place, so I'll put 20.5 here. But in case I want to use it, I'm just going to keep that number anyway. So then the next one is GH. So this one here, I guess I'll just call it Y. Probably the easiest way to do this one is to use tan. You could use Pythagorean since you have this, but if I messed up this value, I don't want it to contaminate my answer here. So I'm just going to do it using the pieces that I already have. So I'm going to use tan of 23 is equal to opposite over adjacent, so 8 over y. So then y is 8 over tan 23. So 8 divided by tan 23 is 18.4468. So 18.8. And then the perimeter is the distance all the way around. So it would be this plus this plus this. So I'm going to take 8 and then I'm going to add the red value and I'm going to add the blue value. So 8 plus 18.8468 plus 20.4744. So I'm getting 47.3 as the perimeter of the triangle. So we're asked to find RS. I guess to make this easier, we will label this X, which is what we're ultimately after. These are the problems, what we call the shared side problems, where you have two triangles and they share a side. And sometimes they look like this, and sometimes they look like this, and sometimes they look like this. But in almost all cases, whenever you have a shared side problem where there's two triangles that share a side, you want to find the side that they share. That's going to be your key to solving the rest of this. So I'm going to call this Y because this is the mutual clue that links this side with this side. This triangle is rich in clues. It's got two things that you know. This triangle is poor in clues. It's only got one thing that you know. So if you can fill this shared side in, then we're going to get this. So first we need to label this triangle. Here's the angle we know. So we're looking at opposite and hypotenuse. So we're going to use sine. So sine of 39 is 8.9 over the hypotenuse. So if you isolate this properly by multiplying both sides by y and then dividing both sides by sine 39, then you're going to get 8.9 over sine 39. Now if you want, you can punch this in your calculator and get it to 4 decimal places. But if you are wanting to keep everything exact until the very end, you can actually just leave this and we'll type it into our calculator later. I think that in this case, we'll get the 4 decimal places because I'm not that good at Calculator Ninja. So 141422. It's just to be safe. So we have this piece and we are looking for this piece. So we got to label this one. So this is adjacent and hypotenuse. So then we're going to use cos then. So cos of 54 is x over y, which is 14.1422. So we multiply both sides by this number, and then I'll have x is equal to 14.1422 times cos of 54. If you want it to be very, very exact, instead of typing this, you could type this, and you could put that in here. Just make sure your brackets are right. But I've actually just left it in my calculator, so I'm just going to hit answer times, and I'm getting x is equal to 8.31. But I'll use 8.3. They gave me 1 decimal place, so I'll give them 1. So this is 8.3 centimeters. Take home message here. Whenever you see a shared side, almost guaranteed you need to find what that shared side is. How do we find an angle? We're only given side lengths and they want us to find angle Q to 2 decimal places. So if I'm standing here, then this is the adjacent and this is the hypotenuse. So we're going to use cos. So we know that cos of the angle Q is equal to 7 over 19. But how do you get Q by itself? Like, how do you get rid of the cos? This is a reminder that to get rid of a cos and to find an angle, you need to use the cos inverse. So then Q is equal to the cos inverse of 7 over 19. And if you find that, you've got to make sure you put it in brackets in your calculator. To 2 decimal places, 68.38. So that's the answer to the first one. But then how do we find these as an exact value? Remember in the first example, I said the moment you punch it into your calculator and you start to round, you have lost your exact values. But is there a way to find these ratios without having to use this angle? So we want to find cos R. So that means that I'm standing in this corner over here. So if I relabel this triangle, this is the adjacent and this is the hypotenuse. And I want this over this, but we don't know what this is. But then we find out that we can actually determine what this is using Pythagorean. So if we take 19 squared minus 7 squared and then we square root it, we are going to get this value. So what do we get? 19 squared minus 7 squared, and then I square root it. But the problem is if you square root it and you get a decimal, it is no longer an exact value. So if you want an exact value, you just leave it the way it is, which is root of 312. Now, if you were all gung-ho, you could change this to a mixed radical, and that may be the answer in the back. But I'm just going to like leave it for a second. We'll get to that later. So as an exact value, we can now take this over that. So adjacent over hypotenuse is root of 312 over 19. That is an exact value. And then sine Q is an exact value. If you are Q, then you're standing here. Opposite over adjacent. So if you're this, then this is the opposite over, opposite over hypotenuse. So again, you're looking at root of 312 over 19. Because if you're standing in the blue corner, this is the opposite and this is the hypotenuse. Now, what if that answer does not match the format of the answer you're expecting? Well, then maybe we need to change it to mixed radical, right? So what is 312? Sorry, that should say 312, not 319. Over 19. Well, let's see if 312 gets divided by any perfect squares. So I believe that 312 is going to be 4 times 78. And then we can pull this out. So it'll be 2 root 78 over 19. And I do not believe there are any perfect squares, any more perfect squares inside 78. I want to know if each of these statements is true or false. Is sine of D equal to cos of F? Depends on what angle you're standing in. So here's sine of D. I'm going to label using sine of D. So this is the adjacent if I'm standing in angle D. Here's the opposite, and here's the hypotenuse. Now, I don't know what this is. I'm just going to label it X for now, but I don't know what it is. So sine of D is going to be opposite over hypotenuse. So that's 3 over X. And then cos of F, I got to relabel it if I'm standing in F. So F, then this is the adjacent. This is still the hypotenuse, but this is the opposite. So cos of F is adjacent over hypotenuse, which is also 3 over X. So these are the same. This is true. That's the first one as well. So if we're looking at tan of F, that means that we are standing in the green corner F, and tan is opposite over adjacent. So that's supposed to be 9 over 3. That's 3. That is not 1/3. It's not even equivalent. So this one is false. Part C says if D increases, then EF will increase. Okay, so what do I mean if D increases? That means angle D, right? This angle right here, if that got bigger, what would happen? Well, let's just for a second draw an example of what would happen. Now, generally when they say that D increases, or one of the angles increase, what they mean is that, yeah, the angle's getting bigger, but the hypotenuse stays the same length. So here's our new triangle with a bigger D, but this is still the same length as it was before. So here is D, but increased. And what then has happened to the length of EF? If you splay out this angle and you imagine this side starting to rotate out, you're going to realize that if you increase the angle, then this side must also increase. So the length of EF will increase if D increases. So this is true. So what about D? If D increases, so we're looking at this red triangle, then sine of D will increase. Well, what is sine of D? It's supposed to be the opposite over the hypotenuse. The hypotenuse has stayed the same length, but what has happened to this opposite side? It seems to have lengthened compared to the old version. And if the opposite side has lengthened, then this will also have increased. So this is also true. What about E? If D increases, then F will increase. So is it true that if we increase this angle, that this one also increases? I have not drawn this diagram very well. So maybe it looks like it did, maybe it looks like it didn't. In any triangle, the angles have to add up to 180. So if this angle stays the same, but you have given more angle to angle D, you actually have to take it away from angle F. Otherwise, the three angles won't add up to 180 and it won't be a good, perfect triangle. So even though I haven't drawn this very well and it looks like F may be increased, if you increase D, that comes out of your angle budget. You only have an angle budget of 180 degrees and 90 of them are already taken. So if you're going to increase this, you better decrease F. So this is false. What about tan of F? So tan of F is the opposite over the hypotenuse. But not as we've labeled it before, because we were always focused on angle D before. So if we're focused on angle F, then this is the opposite, and this is the hypotenuse. And what has happened to that side, that opposite side from the old version to the new version? As we've increased this angle, this side has lengthened, and this side has actually shortened. Okay? So if you want to keep the hypotenuse the same, it's actually not quite correct to have drawn it the way that I did here. If you're going to swing that hypotenuse out like this, then this side has to shorten, that side has to lengthen. So the opposite side to angle F, which is over here, has actually shortened from 9 to something smaller than that. So if this is smaller, then this tan F is also going to be smaller. So this is also false.